Hi, welcome to the session of algorithm. In this session, we'll be discussing what do you understand by an algorithm, followed by the properties of an algorithm. Then we'll move to the steps required in order to develop an algorithm. And finally, we'll be discussing the patterns in algorithm. So what is algorithm? Algorithm is nothing but a finite set of definite steps to accomplish a task. Please remember, whenever you start writing an algorithm, you have to understand that an algorithm has certain steps. You will accomplish a task and it should be finite. Algorithm, it can be written in any natural language like English, or you can take help of any programming language syntax like C programming, Pascal, etc. Such algorithm usually which has typically the syntax of a high level programming language are sometimes called as pseudocode. Let us take an example, algorithm for adding two numbers. Here I've written the algorithm in a basic natural language like in English. Algorithm add, begin, the beginning of an algorithm. Step 1. First step will be accepting the two numbers, that is A and B. Step 2, you can see here, step 1, A and B, and in step 2, we are seeing C is equal to A plus B. Step 3, we are displaying whatever the result which is stored in C. Another form, I'm using certain syntax of C here, open bracket and close bracket. Here even you can remove the open bracket and you can put begin and end also, right? So read A, read B, you're reading the number. A is storing in the variable A here, C equal to A plus B, then you are printing C. Right? So algorithm has a name, so that you can see we are putting a name, that the name of the algorithm is add. So let's recap. Algorithm is nothing but a finite state of definite state. We accomplish a task. As you can see here, the task is nothing but adding of two numbers, and it can be written in any natural language like English, or you can use any kind of syntax of high-level programming languages. Properties of algorithm: finiteness, must terminate after finite number of steps. Very important. Means it need whenever you design an algorithm, it needs to be terminate. It needs to be complete. Next, definiteness. Action in each step must be carried out, must be rigorously and unambiguously specified. Right? It need to be specified unambiguously, right? If I say that X stores into a value 5, again we are saying that X stores values, at a value 5 which is an integer. Again we are saying that X stores a value nothing but a float or a real number, right? So this really makes an ambiguous, right? What exactly X is storing. So there has to be a definiteness in each of the steps that we are talking about. Next, input. Algorithm can have zero input, or it can be have more than one input. As we can see in the previous algorithm that we have discussed, there are two inputs, that is A and B. Output. Algorithm should have at least one output, or it can be more than one. Okay. In the last algorithm, that the addition of the two numbers, we have one output, that is nothing but the value that we get after the adding the two numbers. Effectiveness. Operation must be all be sufficiently basic. Yes, effectiveness is very important. Is it operation must be sufficiently basic? So you're adding addition of two numbers, so you are adding the two numbers, right? Steps to develop an algorithm. First is to identify the inputs and the outputs. Again, we revisit the algorithm addition of two numbers. So we have to identify the inputs. There are two inputs, right? What is the output? Output, we have one output, that is nothing but the sum of the, or the added value of the two numbers. Identify any other data and constant required to solve the problem. Requires the logic. That's what you say. Any other data that can be required or not. Let's take an example. Like if you want to find uh, what is the average of three numbers, right? So in this particular case, there are how many inputs? Three inputs. What is the output? It is average. Is there any kind of other data constant that is required? Yes. If you want to find the average, what is the total number you are taking? That is three. So three, which is a constant value, right? Next, identify what needs to be computed and how to be computed, right? So now let's again take the average of the number. So what you are need to be computed here is the average of the three numbers. How it has to be computed? First we have to add the three numbers, right? Then followed by we will be dividing by 3, because here we are talking about average of three numbers. Yes. So here you can see the everywhere you say it's required a logic, right? That's the reason why understanding the logic, developing a logic is very very important, right? Yes. So you can see my video on how exactly we talk about logic and what are the different type of logic also. And if you have referred it, it's well and good. Sorry. So after that, once you've identified the input, the output, any other constant data that is required, how will you going to compute that? Then start writing the algorithm, right? So simply you take a pen and paper and started, or using a Windows Word, and you started given the problem, started writing the algorithm. No, right? Follow this particular step, understand the problem, yes, right, what exactly it is saying, find the inputs and the outputs, right, any constant that is required, how are you going to compute that, and lastly after you have got this, start writing the algorithm. Yes. Patterns in general, there are different patterns in algorithm. Yes. Sequential, executes the statement in the order in which they appear in the algorithm. Sequential, one after another, right? Yeah, that's what is it. If you refer back to the program, addition of two numbers, you remember the sequence, right? You are taking the input first, then you are adding it, then after that you are displaying the result. Next, selection. Yes, control the flow statement execution based on some condition. Right? We have the explanation in the slide coming up in the next slide. Selection is based on a condition, right? Say if it rains, then I will take this umbrella. Yes, if it doesn't rain, then I will not going to take the umbrella. So a condition, right? The condition is the raining. If it's rain, right? Okay. Next, iteration. Use when a power algorithm to be executed several times. Yes. Say for example, I want to display my name um, 10 times, right? So I'm only displaying my name. Yes. So 10 times, I'm writing print, print, print. Or better, what we can do is that I will take only print statement. Then I will use some kind of certain ways, which is nothing called as the loop also in the programming. Yes. So using that particular loop, I will be displaying the number. That's what is called iteration. Yes. Please understand the entire problem whatever you get can be solved using this particular three patterns, that is sequential, selection and iteration. Yes, the sequence at which it should follow, whether there is any condition associated with it, and if there are certain repeated statement, then how will you going to do. Lastly but not the least is recursive. But understand that whenever you're writing a recursive algorithm and you are translating into a programming language, whether that particular programming will support recursive or not. If not, then again you have to convert that into a non-recursive algorithm. Yes. So recursive intelligence function computed by algorithm are expressed in terms of itself, right? Means what you are saying this, you repeat the function is trying to call by itself. Yes, writing an algorithm, then it started calling itself. We'll see that. Then you will get a better idea about it. Let's take the sequential, right? Yes, I was talking about the average of three numbers. Now let's take this. Find the average marks scored by student in three subjects. So right. So here marks one, marks two, marks three are nothing but the input. And if you see 3 is nothing but the constant out here, and the average, that is what we are taking as the output, right? So we accept 3 marks, that is marks 1, marks 2, 3, marks 3 scored by the student. Then you are adding it up, right? Is that I've written like add marks 1, marks 2 and stored in the result total. Or I can write like total equal to marks 1 plus marks 2 plus marks 3, right? Divide total by 3 and find the average. Or I can write whatever total we have, average is equal to total divided by 3, right? So here typically I have written this complete English like that, you know, English, in a natural language like English. Okay, yes, right. Next, sequential. Find whether a given year is leap year or not. Yes, accept the year. So what is the logic, right? Again, let's come back again, revise once. In this particular problem, what is the input? It's nothing but the year. What is the output we are talking about? Whether it is a leap year or it is not, right? Any constant that is associated with it, yes. Understand that. Then again, you have to get the logic. In order for to be a leap year, it has to be, if you're dividing it by 4, then the remainder should be 0. Or if you're dividing by 100, the remainder should be 0. Or otherwise, if it is divisible by 400, that means the remainder is not there, then also it is a leap year, right? Yes, so you're selecting it, right? So here, if this state, if the year is, say year is sorry, 2000, right? So 2000 is divisible by modulus given 0. If 2000 mod of 100 also, so means 2000 is a leap year. But if I say 2001, it's not. So it comes to the else statement, we will say that year is not a leap year. Yes. Okay, let us move to the next. This is the iteration. Yes, find the average marks scored by n number of students. Okay, right? So I want to find the average for n. Now I have done for average for a single student, right? Same thing, but here I will going to do for n students. So for that I am using a counter here. One, yes, you can see the read marks 1, marks 2 and marks 3. Then I got the average. Okay, yes. Then I'm checking whether student is pass or whether it is fail. If the average is less than 40, then I say student fail. If it is more than 40, then means the student is pass. Okay, right? So here you can see in the same, you have the sequential is a good example where you have the sequential, we have the selection also, and also we can see you are iterating it. So in that particular, you say counter is equal to counter plus 1, and I'm writing right here, if counter less than equal to number of students, then go to step 3. So number of student, if it is 5, so first one I will take the student, then the counter will be incremented to 2, then I take this score, find the average, then whether it is pass or not the second student, then again counter increment to 3. Yes, again I get for the third student, then counter increment to 4, I get the fourth student, counter increment to 5, I get the 5 student, counter increment to 6. Then what will happen here? It will say that 6 is not less than equal to 5. Then what is happening is here the program, the algorithm gets terminated. Yeah. Okay, lastly, sorry, the end. Okay, fine. So algorithm example, the recursive. So find the average of a positive, sorry, find the factorial of a positive integer n, right? Want to find the factorial of a number, right? So I write an algorithm saying that it's factorial. Yes, and if I said if n is equal to 1, I am returning 1, or else I'm writing n multiplied by the factorial n minus 1. What is factorial of 3? 3 factorial is nothing 3 into 2 into 1, right? Okay, let's say now I put 3 here. Now if 3 sorry, and here is 3, so 3 is equal to 1. No, so it will come to the return statement. So it will say 3 into factorial 3 minus 1 means now factorial 2. So again it will go back and call that algorithm and it's come to factorial 2. Again 2 is not equal to 1, again it will come to else statement. So we have here 2 into factorial 2 minus 1. So here we have factorial 1. Now once we come here, it is 1 and equal to 1, so it will return 1. So in this particular return statement the 1 will come. Similarly for it will go back and it will come for the 2, so 2 will come, then 3 will come, so we'll have 3 into 2 into 1. Yes. Okay. Yeah, so ultimately we get the value that is 6. So actually typically how does it work, because we have a concept of stack associated with, stack, right, associated with it. Then also, recursive algorithm, when actually implemented, we have certain kind of activation records and all. So we'll not discuss all these things. Just you understand, in a writing an algorithm, how does it happens is that whenever you write a recursive algorithm, there has to be a terminating condition here, and if n equal to 1, return 1. This is nothing but the terminating condition, smallest interest of the problem whose solution is known. Okay, the solution is known, right? When n equal to 1, you have to return 1. Yeah, then call itself, that's why it is recursive, factorial n minus 1, count for the instance format to previous. So if when I say 3 into 3 minus 1, that is 2, so the smaller instance we are calling it, right? Okay, fine. Right. So no, let's recap the entire thing. So algorithm, nothing but finite steps, right, which actually accomplish a task, right? Then we talked about what different properties of algorithm: definiteness, finiteness. It has to have an input, it has to have an output, it should be effectiveness, right? Then we talk about certain patterns in algorithm, right? So sequential, selection, iteration, and recursive. And I was saying that the first three, I that is the selection, sorry, the sequential, the selection, and the iteration is the basic pattern through which we can able to solve any kind of problem. Hope you have liked this particular sessions. Thank you and do keep watching my videos. Thanks.